In recent wanderings around the internet, I ran into the Luhn algorithm. Luhn, pronounced L-O-O-N, was a mathematician for IBM, and in the 50s, actually 1954, he invented this Luhn algorithm, which is still used in hundreds of applications. And what we're going to do now is look into the algorithm itself. So the algorithm is used in debit and credit cards, in Social Security numbers, in Postal Service package tracking numbers, in SIM cards in all cell phones, Medicare and Medicaid numbers. It's used virtually anywhere someone is required to enter a number, and when you enter that number, you will sometimes see that it is invalid. This is not a sign that it's fraudulent. The algorithm does not check for fraudulence, it only checks for typing errors. So every credit or debit card number will have 16 digits like this. This happens to be 3 followed by 15 digits of pi. It has on the left, the very first number is indicative of the company that issued the card and is ultimately responsible for the payment. My Fidelity credit card is Visa and my debit card is MasterCard. The next 7 digits identify the bank that issued the card. In my case, Fidelity Investments or the North Valley Bank in New Holland, Ohio. The next 7 digits are the individual identification number that's been issued by the bank that issued the card, and this identifies the individual client who's using the card. The 16th and final digit is the one that makes the algorithm work. And the next thing we're going to do is to look into how that happens. The algorithm works in 4 separate steps. So skipping the final digit, we take every other digit and double it. So 9 becomes 18, 5 becomes 10, 2 becomes 4, 4 becomes 8, 3 becomes 6. The second step is then to add together these two numbers. So any number larger than 9 we add together. So 1 and 0 becomes 1, and 1 and 8 becomes 9. The third step is to bring down all of the numbers that we can see. So we bring down a 6, a 1, an 8, a 1. We bring down the 1, we bring down the 9, the 4, the 6, etc. all the way, and then we add all of those together. In this case, it adds up to 80. The fourth and final step is that we divide 80 by 10, which is the same thing as saying mod 10, and we look for a remainder. If there is no remainder, then our spelling checks out and the card passes. Okay, this is the program. I call it the Luhn Algorithm Credit Card Validator, but it could actually validate any number. I think the minimum number would be 3. And all it's doing is checking for typos. Step 1, we iterate backwards from the rightmost digit. And step 2 is we double every second digit. Step 3 is if doubling results in a 2-digit number, then sum those 2 digits. Like if it's 14, you add 1 and 4 to get 5. So that's the third step. And then the fourth step is to validate by doing the mod 10. And if you have any remainder, it's not valid. So anyway, this is the process of the sum of those numbers. So here is the program, just like that. If the valid number were the green one, ending in 6, then if you mistyped it and entered it in 7, it would be invalid. If the top number, this is like a actual credit card number. If the actual number entered in 0 and you typed in 8, the program would find it to be invalid. And that's it. So thank you for watching.